Welcome to TOC class. Here there is a problem for conversion of MPCP to PCP. They will give the question like this, that M is equal to 7 tuple values. This is Q, sigma, tape symbols tau, tilde. So tilde is given as a tabularized format and the starting state is Q1, tape symbols are blank space and final state is Q3. They will give the tilde value and they will give the input string 0, 1. If the question is asked like find a solution, means the solution is the conversion of MPCP to PCP. Instead of that, the same question is given like this, find a code. If the question is asked as find a code or encode the Turing machine, means we should use the encoding format capital M. So capital M is equal to 111 M1 like that. So I already give the solution for encoding format. So you please refer the encoding of Turing machine for the same question. So the question is given as it is. But instead of a value find a solution, if they ask find a code, means we should use encoding technique. If a question is asked like find a solution, means we should construct a rule by using a rule table format and we try to equalize list A and list B. So I already give the rule construction notation. So there are 5 different rules are available. First rule is framed with the initial state and the given input string. Second rule is for tape symbols. Third rule is for transition functions notations. Fourth rule is for final states with some dummy symbols at both left and right side. Fifth rule is with final state ending with hash. So here hash is considered as blank space. So first we should construct the rules. So how to find a solution for this problem? In step 1, we should write transition flow checking. For that we are taking starting state. So starting state is given as the 5th parameter. So you write the given values. So given values are starting state is Q1, final state is Q3 and the input string W is 0, 1. So these are all written as a first step. In step 2, we just validate the table with the input string 0, 1. So the validation is already given in a Turing machine construction. That means context-free language to Turing machine. That problem. So that problem contains 4 steps. First step is we should write the procedure. Then second step is transition table construction. Third step is transition diagram construction. Fourth step is the validation. So that validation should be written here, step 2. So initial hash symbol, starting state is Q1 and the given input string is 0, 1. So I want to check Q1 0. So you marked it. So this is Q1 0. So I want to check Q1 0 from the given table. So if you take Q1 0, instead of 0 you should write 1. Instead of Q1 you should write Q2 but right side. So Q2 should be written at right side of 1. So you write 0 for 1 and Q2 should be right at right side of 1. So 1 Q2. The remaining symbol is 1. Now I want to check Q2 1 from the table. So you go to check it, Q2 1, it is Q1 0 right side. So instead of 1 you write 0 and Q1 should be written at right side of 0. So this is Q1. And no values after 1, only hash symbol is there. So I want to check Q1 hash from the table. Q1 hash means blank space. So either you can represent it as blank space or hash. So instead of hash you should write 1 and Q2 should be written at left side of 1. So hash, instead of hash I write 1. Q2 should be written at left side. The left side value is 0. So at 0 left side I am writing Q2. So now I want to check Q2 0. So just check it out. 0, the same 0 is there. Instead of Q2 you should write Q3, but that should be written at left side of 0. So the same 0 is available and its left side value is 1, you just write it, and then its left side value is Q3. So you go to check Q31, there is no notations, that means it is an accept state because Q3 is the final state. So if I am reaching Q3 means I can stop the procedure. So it contains 1, 2, 3, 4, 5 steps. After 5 steps only the accept state will occur. So this is the prediction. I want to check the same flow at the validation phase. Step 3 is the rule table construction. There are 5 rules are available. The given strings are W equal to 0, 1. Initial state is Q0. So you should write list A with only hash symbol. In list B, we can write it as hash followed by QW. Q means starting state. Here starting state is Q1. Then 0, 1 hash. The tape symbols are, this is the third parameter, tape symbols are 0, 1 blank space. So any symbol is available in list B, you can also write it in list A up to hash. Then tilde, there are 6 different functions are there. So I am writing 6 different functions here. Then I am only taking right side value here. So right side Q1 0, instead of Q1 0, I can write it as 1 Q2. Here Q2 1, 0 Q1. Q2 blank space, 0 Q2. So these 3 are framed. So instead of this value, I want to write this number. This is the answer. Left side means you put Z value. Z may be 0, 1 or blank space. So we can frame these notations based upon the previous rules. And the fourth rule is final state Q3. At left or right side, either the symbol 0, 1 or blank space can occur. If it occurred, you can omit one by one. And at last, if Q3 is framed with hash, you should put a double hash at list A, single hash at list B. So how can we check it? This is the validation phase. So by using, I want to frame two lists, A list, B list. By applying rule 1, A list contains only hash, B list contains hash starting state followed by W value hash. So this is framed with rule 1. And I want to frame second step. So how can you write second step means what are the extra symbols are available? It is Q1, 0, 1 hash. So up to hash you write all the values to list A. So you copy up to hash all the values to A list here. Then you want to check Q1 0. So I already write the answer for Q1 0. It is 1 Q2 1. So you write that value 1 Q2 1 hash. So this is framed with rule 3. So rule 2 and rule 3. So what are the 0 and 1 symbol hash symbols are available, that will be copied to list A based upon rule 2. And rule 3 is framed with these notations. So you just check it out. Instead of Q1 0, you should write 1 Q2. So I am writing instead of Q1 0, I am writing 1 Q2. The remaining symbols are 1 hash. This is rule 2 and 3. So up to hash you write all the values from list B to list A in step 3. So you copied here. Now I want to check Q21. So just search here, where is Q21? It is Q21. The answer is 0 Q1. So you write 0 Q1. Up to that the answers are copied at rule 4. So like that it will be occurred. So at one situation Q3101 is occurred. If you want to check Q31, there is no transition function for Q31. So you can't apply rule 3. And you want to check what is the Q3 state. Q3 is the final state. So I am going to rule 4. If any final state occur, and after final state if there is any symbols are occurred, you just skip one symbol at a time. So if any Q3 with 101 is available, you just skip only one symbol at a time. So in step 6, only I skip 1. So the remaining values are Q301. In step 7, I skip 0. So the remaining value is Q31. In step, this is Q31. In step 8, I skip 1. So only Q3 has occurred. So these in this way 5, 6, 7, 8 steps are occurred. Then Q3 hash. It's not available in rule 4. You just check it out. Fifth rule is final state followed by hash. If it is like that, list B, you only write one hash In list A, you should use double hash. So if you fill it, these two lists are same. So these lists are same after implementing 9 steps. So if two lists are equal, then we can able to find a solution based upon these conditions. So let us consider the second problem. Here 5 states are there, Q0 to Q4. Starting state is Q0, final state is Q4, and the tape symbols are 0, 1, X, Y blank space. So this is a stable. By using the previous solution, you try to find a solution for the string W as 011. So the string is 011, starting state is Q0, final state is Q4, and the tape symbols are 0, 1, X, Y blank space. So you can write it as Z here. So these are all the tape symbols. And you apply step 1 to 4 for finding the solution. In step 4, list A and list B should contain equal values. So in this manner, we try to solve the solution for a given problem. So this is also called as MPCP to PCP conversion. Thank you.